this too. Dadgummit. By the way, I got an iPad. Now I just have to figure out some technical shit. Go away, okay. That's a little better. No glare, okay. Number 20? 5-1? 5.55, okay. 5-3 at the moment. Yeah! All right, there we go. Yeah, okay. So the nice thing with this one, so they ask you to use the factor theorem, and the factor theorem just says if you find all the zeros, you know how to factor it, like we just did, right? If I know a 0 is 2, then I know x minus 2 is a factor. They gave us one factor, which is awesome, because what's the worst thing about this stuff? Can anyone tell me what's the worst thing about trying to find all the zeros in some big-ass polynomial? A lot of guesswork. You construct your list and you watch it grow and you're like, God damn it. So then you have to try and come on. So what's really beautiful about number 20 is they told you something that works. Right? So what am I going to synthetically divide by? 1. And what am I going to be careful about when I go to set it up? It's missing x squared. So I better put what coefficients? 4, 0, -7, 3, yes? Is that cool? And you put a little 1 in the little penalty box and you go to town. Anytime you synthetically divide and you get to a quadratic, you do not need to synthetically divide anymore, because either that factors or you have to use quadratic form. Once it's quadratic, we can handle it. I don't need any help anymore. Thank you, synthetic. Is that right? Okay. Anything else from homework stuff or generally? You guys doing okay? Yes?
So what problem do you have to find 3 zeros?
Yep. Just to remind you, some could be complex, some could repeat. So I can have a 5th degree thing and the only answers are 2. 2 is the only answer, but it shows up 5 times, right? Like x minus 2 to the 5th. There are 5 answers, they just all happen to be 2. So if I ask everybody, yes or no, blah, 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 I'm not going to say I got 1 yes and 1 no. I'm going to say I got so many yeses, even though they're repeats, that's how many of them. Does that make sense? It's kind of like the same idea. Okay. I like it. So the nice thing is when you see the highest power on a polynomial, you must end up with that many answers. That's kind of nice. It has to do with how many times you could turn back around and hit the x-axis some more. Possibly in the imaginary numbers, right? Okay. Anything else from homework stuff? Okay, let's do this. I was talking to somebody earlier. The very first thing I want to show you is this example. What to do when I'm synthetically dividing by something that doesn't have a 1 leading coefficient. So I have no idea if this is going to come out nice. So we're all just going to try. Yeah, this might be worse than I want it to be. Let me think for a second. It is going to be worse than I want it to be, but it's too bad for everybody. Ha ha ha. No, let me make this a little better. There. Make it 2x cubed plus 6x minus 4. Synthetic division only works directly if I have x plus or minus a number on the bottom. That's one reason why it's so freaking powerful, is it only works in very specific situations. Do I have that situation? No, damn it. So here's the way to look at this. Okay, real quick, just to show you 2 ways to kind of look at this. What goes in the penalty box always If I had divided by x minus 7, can somebody tell me what would go in the penalty box? 7. What always goes in the penalty box is what makes the bottom 0. So what makes the 0? Negative 1/2. So I'm going to pretend like I heard. Right? I mean, you're right, but don't do that. Okay. Now, another way to look at this. I'm going to come back to you. Don't worry. Let me see if you guys are really cool with this. You all agree I need a 1? And you're all like, yeah, because that's what you just said. So if I factor a 2 out, can anyone tell me what would be left? If I take a 2 out, is anybody concerned that 1 can't have a 2 come out of it? Of course it can. Right? What's 2x divided by 2? X. And what's 1 divided by 2? Now I can see even better. It's just the same way that's a 7. This is going to be a negative 1/2 in the penalty box. Is everybody with me so far? So when you're doing this, if you do this from the beginning, the answer you get is not the answer yet. Because how many things is this really asking me to divide by? 1, 2. The answer I get is going to be twice as big as it should be, because I haven't divided by 2 yet. Guys, if I said what's 50 divided by 4, does anyone know a good way to do that in your head? You could do 50 divided by 2, divided by 2. What's 50 divided by 2?
25.
And what's 25 cut in half? 12.5. So it's an easy way is to break the 4 up into 2 parts, divide once, and then divide by the next. So it's I'm going to divide synthetically by this, and at the end, I better frickin' divide by 2, because I haven't done that yet. You were with me? So we all know that since synthetic division only works when there's a 1 coefficient, leading coefficient, it's going to get a little freaky if it's not a 1. Same thing with factoring, right? Same kind of idea. So help me out. What do I put up top here? What do I put? So I'm going to do this. So I put my little negative 1/2 in the penalty box. I'm sure you guys are all very excited about that. What goes up here? 2. 0. Good. 6. Negative 4. Shabbat. So then I'm bringing down a 2. What's negative 1/2 of 2? Negative 1. Add. I still didn't make it nice, did I? Too bad for everybody. What's negative 1/2 times negative 1? 1/2. We're all going to be okay. We're going to be okay. What's 6 plus a half? 13 halves. What's negative 1/2 times 13 halves? Negative 13 fourths. And then what's negative 4 minus 13 fourths? Negative 29 over 4. Good. And of course, this is not the answer. I have to then divide all of these by 2. So this will be 1 minus 1/2, 13 fourths, negative 29 eighths. And then I can write the answer. What would the answer be? It was a cube, so now it's a square. So this, I can make this look a little bit better. Bring the 8 down. So it gets really, really exciting when the first number is not a 1. So I think you have like a couple in the problem set like that. Okay. That's the one situation where synthetic division sort of gets a little wonky, but it's just whatever coefficient you have out front, you're going to still put the thing that makes it 0 in the penalty box. You just have to remember to also divide by it at the end. Okay, I know that. Anything else? Yes?
So remember at the end of your synthetic division, and you only put like one number in the beginning, like usually you're like, 4x, like, 2, 4.
Yeah, so since are you talking about the powers?
Yeah,
So it was a cube, so when I divide by x stuff, it should end up being a squared now, the first one. Right, if I just kind of look at this, 2x cubed divided by 2x is x squared, right? So that's why anytime I do this division once, I'm going to lose an x. So all my coefficients now are coefficients of one less x than they were before. And it really is just 2x cubed divided by 2x is x squared. So that makes sense that that's there.
Unlike the homework problems when it just has like x on the bottom, then just the first coefficient just stays the same, so that you just have like
Do you mean like this step here?
um
Or do you mean if that wouldn't have been there?
if the two would have been
Then I would have just put a -1 in the penalty box and I would have divided and been done. Right? I'm not sure what the question is. So if this 2 would have been there, you would have done it like every other problem we've done so far. Right? You would have put a -1 in here, correct?
Yeah.
You would have synthetically divided and then you would have been done. I wouldn't have to have done this. Right?
But if we I don't know. When I'm trying to find like multiple zeros, there's only like a zero at the end, and I feel like the first coefficient keeps on dropping down to like the bottom, and once you get one number and zero, once you already found all of your like zeros in like little boxes.
Okay. So I think you're saying you see something happening all the time, and for most of our problems, there will be some similar things happening because most of our problems have like a 1, which means whatever this number is just going to kind of come for the ride. Right? I mean, does that make sense? So most of the time, when we synthetically divide, we're dividing by something with a first coefficient of 1. If I divide 2x cubed by x, the 2 doesn't change. So that's going to kind of like come for the ride forever. Is that what you're saying?
Yeah, and then it's at the end, so once you already have all your zeros, do you put it in front of it, or?
The number that you end up with here,
Yes.
that's going to be the coefficient of whatever x power you're at. Okay, I'm not sure. Do you have a specific problem you're looking at, or?
Yeah, when I'm trying to do, let's say from like section 5.520.
Am I there? Oh, this one. Okay. All right, let's take a look at this. Can everybody write that down in synthetic division notation? Number 20. So everybody got that? Hopefully you wrote this. So then what's the first step? Bring the 4 down. Multiply. Add. Multiply. Add. Multiply. Add. Now, hit me with your question now that I can see it.
I just guessing that you have a zero, so I put like 1/2, and then 1/2, and then I got.
Oh, why would you guess 1/2? Tell me this real quick. Okay, I'm going to do a couple things. I'm going to go a little further, and then I'm going to remind you why you don't have to. But can you tell me what we currently have? What does this actually mean? 4x. Because what was it originally? Cubed. So now I divided once by x something, so now it's squared. Yeah, so it's before x squared plus 4x minus 3. Oh, I see. Okay, so 1/2 could work. Okay, I'm with you. But if you look again, there'd be factors of 3 divided by factors of 4. So 1/2 could work, sure. And then, so, okay, did you get 1/2 to work?
Yeah.
Okay, good. All right, let's do this. Okay, let's just power through. Here we go. So what am I actually dividing by when I put a 1/2 there? So I to be honest, okay, let's do this all the way. You ready? Let's do this. So down comes a 4. Half of 4 is, that's crazy. 4 plus 2 is 6. Half of 6 is 3. So then that's 0. Okay, so watch this. You ready? What did this relate to? X minus 1. What did this relate to directly? Directly.
2x.
I'll do it. X minus 1/2. Yes? Whatever number's in the penalty box, isn't it X minus that number?
Yes.
Okay, good. And then what's this? It started off as cube. Here it's squared. Here it's
X.
first power, 11. Now watch. You ready? This will always happen. Doesn't this have an extra factor of 2? You with me? So then I can make this x minus 1, x minus 1/2. I can take a 2 out of this. And then I can put the 2 in there. And I can make that little dude a whole dude. Chabow! Is that cool?
Yeah.
So, I like it because that's kind of like the reverse of what we did earlier. When you get this to work in a problem like this, you write down specifically it's x minus whatever the shit. And the nice thing is almost always some other piece is going to have the factor that will make him a nice whole dude. If you just stop here, I'm not going to complain that much. I might put a little note. But you could bring a factor 2 there and make it look a lot better, right?
Mm-hmm.
Now, what's the ultimate thing? Did we have to do this? I did not have to do that because can't you just factor this? Factors in negative 12. Are you dying? Dang. This is another reason I want my iPad. Let's see. There we go. Factors in negative 12, that add to be 4, right? 4 times negative 3, negative 12. Factors in negative 12 add to be 4 would be 6 and 2. 2's got to be negative, 4x squared, minus 2x plus 6x minus 3. I'm just going to do this a little quickly. 2x minus 1, plus 3, 2x minus 1. So I get 2x plus 3, 2x minus 1, which is exactly what we got over there. All right? I did that quickly. I don't care because you guys, we already did all that crap. Yes? So when you get to a quadratic, unless the problem says do synthetic all the way, I don't think anyone does. When you get to a quadratic, you don't need synthetic anymore. Unless you want to. I mean, sometimes it's just easier to just keep going. But you can just write it over here, and then you can factor it. Or a quadratic formula if it needs roots and it won't factor. Yeah, okay. Is that all right? So this will work. Just got to be a little careful again because it's a freaking fraction, right? But you don't need to for this problem. It's a quadratic. Okay. Good question. I like it. So these are the little, side details that get a little rough. I just really desperately want you to understand synthetic division itself directly. Fractions are a little bit of a detail, but hopefully that makes sense how they kind of work. Okay. Anything else from homework stuff or generally? Yes. 3 on the quiz. Oh, all right, so help me out, guys. Everybody had this problem, but nobody had this problem. Yes, Jeff, you're very funny. All right. How do I put that into standard form or vertex form? Did I say you could use the shortcut on the problem? No, I did not. So do not use the shortcut. How do I put this into, because I said put this into standard form, find the vertex. See, I put find the vertex second. So don't do the shortcut, find the vertex, and then force this into the form. No. What, anybody know the first step? And what do I?
Cut negative 16.
Nope. Okay, okay.
Oh, yeah,
So let's move the 3. But just like synthetic division, what does completed a square require?
The coefficient.
Yes, that's a 4. It needs to be a 1. So let me take a 4 out. Now I can focus on what to put there, right? So inside, now hit me with the first step. Hit me with the first step.
Cut negative 4.
Yeah, negative 4 cut in half is negative 2 squared is 4. So I'm going to add 4. What did I actually just do?
16.
I added 16, so I better subtract 16. Does everybody get that? Right? If I give you $10 and then I take $10 away from you, you're in the same financial situation. Thank you, Jeff, right? So if I give you $16 and I take $16 away, I did not change your situation. And then what's this? Half of -4 was -2, right? The first step of completing a square tells me how it's going to factor. And what do I get out here? So what's the vertex? 2, -13. What's the y-intercept? What is it? 0, 3. Kick ass. Do the y-intercept, do the vertex. You can get another point by symmetry. Right? So if I do this very quickly. 2, -13. This is not good enough for me. 0, 3. Holy shit, Jeff. So let's say it's right there. So I can get another point by symmetry. So then I've got, I don't know if you guys can even see that. So your graph better be more detailed than that. But plot the vertex, plot the y-intercept, get the other point by symmetry, bam. Some of you guys are getting way too many points. That's missing the point. You should not have to make a table of values with what we know. The more you know, the less you should have to do. Okay. All right. 16, 18, 19. Okay. Missing 8 people. All right, guys. Let's do this. I think we did this one. We finished the front, I believe. Is that true? I don't have the one I marked up for whatever reason. Does everybody have this handout? Anybody need this? We just didn't finish the back. Well, before I forget, what's happening tomorrow? Yeah. What? It was 4. And what did I say? It was 5-2 to 5-4? Yes. Alright, this is good because this is for Jeff tomorrow. So he's like, did I say there was a quiz? Yes, you did, Jeff. It's right there. So we did this side. I'm pretty sure we finished this, yes? Did we do that one too? Yes. No?
Yes.
Yes. Thank you. Okay, so now let's look at the back. That's right, because I made the big old joke about let's do this, no we won't. Okay. So take a minute. If you haven't done this yet, do part A and part B, and then I'll catch up to you. Or just, do as much as you can, and then I'll start to catch up with you. Of course, this is one where you're going to have fractional possibilities, right? so I'm gonna kind of catch up to you guys. So the top is all the factors of 8. The bottom factors of 3. We really don't need that plus or minus, but that's all right. And don't forget, don't lose touch with why that's true, because I know if something's in front of the variable, so if I have like 2x minus 1 and I go to solve it, I'm going to end up dividing by that number in front. That's why the number in front ends up being the bottom somewhere. So then I always get 1, 2, 4, 8 divided by 1, plus or minus. And then I start to get my 1/3, 2/3, 4/3, 8/3. So that list kind of sucks a bit. How many things are in that list?
8 or 16.
There it is, 16. Yes. What about part B? How many changes in sign are there in the polynomial that we were given?
4.
Yeah, 1, 2, 3, 4. What does that mean?
It's 4, 2, or 0.
The number of possible positive reals is 4, 2, or 0. And if I look at p of negative x, what would happen if I plug a negative x in? Yeah, all the odd ones would change sign. So then I have plus, 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 plus. No sign changes. And what does that mean?
No, 0.
0 negative real roots. I like it. That's beautiful. That's when Descartes really helpful. So it doesn't work all the time, but when he does, 60% of the time, he helps it out 100% of the time. So has anyone done this part yet? Part C? All right, hang on. Let's see. So if I divide by 4. By the way, what does that really mean I'm dividing by?
X minus 4.
X minus 4, cool. So I'm not missing any terms, yes. So I'm just going to put down 3, negative 7, 14, negative 28, 8. Yes?
What was the 2x minus 1? What was that for?
Oh, I'm sorry. That was just me trying to remind everybody why the first number is on the bottom. Because if I did solve this, I would get 1 divided by 2. So the numbers out front are the ones that would end up on the bottom. Yeah, that's why the last number is on top, its factors, and the first number is on the bottom, its factors. Yeah. So we're all done this a lot. Help me out. Am I doing anything wrong? Hopefully not. 136, I think. Big positive, big positive, big positive. I get to a point where I just know it's not going to work. So then who cares about the numbers? Now what am I looking for? What do I care about now? Is everybody really with me on this? At this point, I'm like, this is never going to be 0. I just know it's not going to become 0. So now I start keeping track of the signs. Why?
To see if it's an upper bound.
Yeah, so now I divide it by a positive number. I see no sign changes. Therefore, 4 is an upper bound. Upper bud. It's trying to be bound. Yep. Okay. So let's see. 2 things I can throw out of my list. I could throw, well, more than 2, but 2 categories. I could throw out every number that is negative, and I can throw out 4 and up. Upper bound. So nothing above 4 works. So then this will be 1, 2, 1/3, 2/3, 4/3, 8/3. So that's my list now. Still big, but a lot better than frickin' 16. Yes?
In what way would you be able to tell if it was like 4 is lower bound? Like what?
Oh. So when I divide by a positive number, if I see no sign changes, upper bound. When I divide by a negative number, if I see nothing but sign changes, bam, 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 that's a lower bound. It's directly connected to Descartes' rule of signs. Yeah. So could I see that 4 is a lower bound? No. Divide by negative, nothing but sign changes. It changes every time. That's a lower bound. Divide by positive, I don't see any sign changes. That's an upper bound. Okay, let me stop for a minute. All right, now it's just, time to guess. So what I'm going to try to do in a test, obviously, is make it so that the list is smaller than this. Because you could be that unlucky person that just tries everything until, you're like, oh, so has anybody tried any of these yet? I might have caught up to everybody. All right, everybody pick one. Try. Let's see who gets one that works. I'll try one too. I'll just pick a gross one. I'll try 4/3. Watch this work. I don't even know. Let's see. Oops. Ooh, that's not going to work. Did I do that right? Let's see. Yeah, okay. So that's 40/3. Nope. Because I know it's not going to become 0 is the trick. Yes?
2 works.
2 works? Okay. You guys are better than me. I picked the gross one. Let's see. 3, -7, 14, -28, 8. 3, 6, -1, -2, 12, 24. That's a -28, Jeff. -4, -8, 0. Yeah! That's right. Is this quadratic yet? Does anyone see it in this specific instance? I could stop doing synthetic. Do you all agree with me those are coefficients of the x stuff? Do you agree with me that if I take a 4 out of these, doesn't this become 3 minus 1? 3 minus 1. If I write this cubic down, couldn't I group it and I can see it would work? If you didn't see that, is it the end of the world? No, just keep doing frickin' synthetic. Did anyone get it? I don't know if you guys are really with me. If I stop right now, can somebody tell me what this represents?
3x cubed.
Yeah, because it started with a 4th power, so it's 3x cubed
Minus x squared.
minus x squared, 12x, minus 4, yes? And see how grouping will work? Okay. If you don't see that, you could just keep going. Not a big deal. Did anyone get another number that works? Could 2 work again? Yes. So let's see. Would 2 work again? I don't. No. No. Did anyone get another number that worked? Anybody try 4? Anybody try 1? Huh?
1/3.
1/3 works? Okay, let's try it. So 1/3. Let's see. So I get 3. 1/3 of 3 is 1. I get 0, 0. 12. 1/3 of 12 is 4, 0. Now am I at an x squared?
Yes.
Yes. So what do we got so far? Help me out. We got 2 to work. What's that? X minus 2. We got 1/3 to work. What is that? That's good. And then we left with 3, 0, 12. So what does that mean?
3x squared.
Plus 12, 11. Does someone see that cleanup thing that I did earlier? What factor can come out of these?
3.
3. So I can just put a factor of 3 in there. X minus 2, 3x minus 1, x squared plus 4. So what do we get for the real zeros? We got 2 and we got 1/3. What if I said find all the zeros? Have we found all the zeros yet? How do I know I definitely haven't? I had a 4th degree. I've got 2 things that happened once. I need 2 more things, don't I? And what are the other two things? What kind of numbers are the other two answers? Complex. Because x squared plus 4, what would their zeros be? You know it. 2i, negative 2i. But in this problem I said real zeros. So you don't have to worry about getting the complex ones. If you do, I'm not going to take points off because I will cheer for you, but you don't have to go that far if I say real zeros. Okay. How are we feeling? Okay. So, if you haven't gotten in there and tried that homework out yet, please, dear God, do. So we're about to move on. We are crazy people. Just to make sure, so tomorrow we have the quiz, of course. What's happening next Tuesday? Our next test.
Exam.
So what am I going to give to you on Thursday?
Review.
Practice test. So on Monday will be review. I'll have the answer key. So today and tomorrow we'll be doing new stuff. Monday will just be review for the test. Okay, let's do some new stuff. So we got section 5, 6 now. Because we're all right. 5, 6 deals with functions that look like this. What kind of function is that? Rational. I love it. It's just a ratio of two polynomials. So math people being very creative. It says ratio, let's call it rational. Okay. Can anyone tell me, does this function freak out anywhere? Are there some values that this function cannot handle? Yeah, you can tell if you do what with the bottom. And to make it 0 easy, you just factor it, right? So where are the two places this thing freaks out? Yeah. X can't be 4, negative 4. So what I want to do is I want to try to focus on, well, what the hell happens there? I know it can't be 4, but what does that mean graphically? Right? Does that just mean I'm going to put an open circle there or something? What does it mean? So let me give us an easier one. Let's look at one of these situations. Let's look at this function instead. Okay, so where does this function have a problem? 4. So let's do this. We can do this without a calculator, believe it or not. What I'm going to do, now here's something really nifty. This is an idea that carries over into calculus. And I might try to use some calculus notation just in case you're going to take calculus. 4 is a freaky ass input. So I'm not going to put a 4 in. But could I put like 3.9 in? Yeah. So what I'm going to do, when there's something really weird, if you see something kind of weird over there, you're going to go, what is that? You're going to get close to, are you going to touch the damn thing? No, because my favorite example is the movie The Blob from the 80s. That was a good Blob. Has anybody ever seen that movie? It's not a prerequisite you've seen. So at the very, very, very beginning, this meteorite crashes to Earth, cracks open, and this ooze comes out. So what's this guy do? He does what I would do at first. He goes, what is that? And then he freaking touches the damn thing. Well, he does it with his stick and whatever. He goes, no. Horror movies happen that way. And it's sure enough, it ate everybody in the world. Okay. So what we're going to do, 4 is the blob creature on the ground. We ain't going to go to 4. We're going to go close to 4. Because we're humans. We're curious. We're like, what is that? That's weird. I think I'm going to walk this way. But we're going to get closer first. Okay. So watch this. We're going to do this without a calculator because we're crazy. So what I want to do you all agree that 3.5 is kind of close to 4?
Yeah.
Can I get closer? 3.9 is pretty close. Can I get closer?
Yeah.
Yes. 3.99 is pretty close to 4, Jeff. Now, what if my buddy's on the other side of the blob? I'm like, hey man, come over here, come over here. So I'm coming from this side and he's coming from that side. So what's on the other side of 4?
4.01.
I can do 4.5, 4.1, 4.01. So this is me and this is my buddy. And we're kind of approaching this little blob, ooze, crazy, weird shit. Okay. So when I plug a 3.5 in, I do not need a calculator for this crazy shit. What is 3.5 minus 4? Negative 0.5. Negative a half, yes? What's 1 divided by a half? 2. And there's a negative, so this is negative 2. That's negative 2. So we're humans. We're better than that. We don't need a stupid calculator. 3.9. Can we all think in our heads 3.9 minus 4 would be 0.1. What is 0.1 as a fraction? Negative 0.1, right? But what's 0.1 as a fraction? 1/10, because our decimal system is based on 10 for some reason. Who knows why? So I get 1 divided by negative 1/10. That's 1 times negative 10. I get negative 10. So who thinks they know what's going to happen here? 1 decimal, 1 decimal?
Yeah.
I'm sorry, 1 decimal, 1 0. 2 decimals, 2 0. So 3.99 minus 4 is negative 0.01, which is negative 1 over 100. 1 divided by that is negative 100. When I divide fractions, I multiply by the reciprocal. So if I kept going 3999999, what do you think this number is going to do? Keep getting big negative. So let's come from the other side. The only difference with this side is when I put a 4.5, I get positive 1/2. So I'll get positive 2. When I put a 4.1, I get positive 1/10. So I get positive 10, positive 100. So when I go this way, it's approaching negative infinity. And when I'm going this way, it's approaching positive infinity. Because how many zeros can I put between 4 and 1? As many as I want to. And every time I put another 0, I put another 0 here, yes? So I can make this number as big as I want to. That is what infinity is. Infinity is not a location. Infinity is not a number. It is a process. If I keep putting zeros in there forever, that's infinity. That process. That's why it's weird to say half of infinity is infinity. But that's true. If I go as far as, how do I say this? If I keep putting zeros in, but I do it half as quickly, aren't I still going to go to infinity? So that's why half of infinity is infinity. I'll stop. Because infinity is weird. Okay. Let me show you what this looks like in calculus speak. Do you guys agree that we never can get to 4? I can never just put 4 in, because then that's undefined. Right? So what we call this in calculus is we call this a limit. There's a limit. And in this case, is there really a limit? We would actually say the limit doesn't exist, because is there a limit to what I can get out? No, I can get as low as I want to on one side, as high as I want to on the other side. So I would say the limit, and what are we letting x get close to? 4. The limit as x goes to 4 from the left of this weird s function is negative infinity, and the limit as x goes to 4 from the right is infinity. How important is this notation for everyday use in pre-calculus? Not. But I just kind of want to show you, this is what that symbol means. That means, what does it look like this function's doing as I let my input get close to this? The little negative just means I'm coming from the left of 4. This one says, what is this function doing as I let my inputs get close to 4 from the right? Well, it's growing crazy big. Yes? Okay, let me stop for a minute. Time's, oh, good. All right. Too bad for you, but we got time. Now, what about, so here's one freaky thing. So we still have to talk about what is that going to look like graphically. Yes? But we'll get there. What about, in fact, let me do this right now. So we got g of x, 1 over x minus 4, and we know that Good try. It's not my tongue. Negative infinity, and we know this is positive infinity. So what does that mean? That means, Jeff, good job, buddy. Everything's happening over here. Okay. When I put a 3.5 in, we got negative 2, yes? When I put a 3.9 in, we got negative 10. When I put 3.9 in, so this is what's called, does anyone know the name of this thing?
Vertical asymptote.
Vertical asymptote. I like it. Make that big. And on the other side, because I'm so nice to myself and give myself so much room, the same thing's going to happen except it's going to go up. So now I still am curious what's happening over here, yes? What's happening as I go that way? Instead of getting really close to 4, what happens when I get really far away from 4? What's that function going to do? So let's look at that then. So let me go back to real quick. Where do you think this guy's got a vertical asymptotes? Why does he have more than one? Because what two things freak it out? 4, negative 4. So it's going to have a wall at 4 and a wall at negative 4. It's a freaking literal wall because it's saying you cannot go here. And what I love is, just to show you how big of a geek I am, it's a trap. And they should pull it because the damn shield lock generator is still operational. Damn it. Okay. If you don't get that, it's okay. So what I want to do now is, well, I know what it's doing when I get close to 4. What is it doing when I get far away from 4? What's it doing? So let's try to get far away from 4. So let's plug in. Let's go this way first. Let's plug in some big-ass numbers. So let's plug in really, really crazy big, like 14. That's not big, but can anyone see what I get if I plug a 14 in? Do you guys see why I picked 14? What do you get when I plug a 14 in?
1/10.
Yeah, 1/10. What if I plug a 104 in?
1/100.
1 over 100. Do I have to pick these numbers? No. I'm picking them because it's easy to do by hand. But the same thing would happen no matter what numbers I put in there. So I can keep going, but you guys see what's happening. So as my inputs get bigger, my outputs are approaching 0. So the limit as my inputs go to infinity is 0. So what's it going to do here? There's going to be an asymptote at 0. I left myself no room. Jeff, just do this. There you go, buddy. It's going to go like that. You guys have seen graphs that do that, I'm sure, at some point. And then how do I investigate the other side? Well, I just put in negative big. So like, I'm going to be smart again, put negative 6 in. It's not very big, but it's, I get negative 1/10. Negative 106, let's just go there. Did you do it, Jeff? No, you didn't do it, buddy. You can try better. Negative 96, there we go. Negative 96 would be negative 1 over 100, yes? So again, it's still approaching what? The outputs are getting, the bottom is getting bigger, which means the whole thing is getting, when I divide by bigger, I get smaller, yeah. So the limit as x goes to negative infinity is also 0. So back here, it's going to do this. So I've got an asymptote right there. I've got a horizontal asymptote right there. So I just wanted to take today, we still got some time, to lay some groundwork as to why these asymptotes exist, why they operate the way they do. Just to say that, I'm going to say this a few times. This is a literal wall. It cannot go through this. Horizontal asymptotes are just suggestions. Oh yeah, eventually, can you get close to me, please? So later this semester, we're going to see things that look like this. Yeah, woohoo. Right? I don't know if you guys know what that is. That one specifically is a cosine. Or you can say it's a shifted sign. So I'm okay. So I could have, has anyone played guitar or anything? Or some kind of a string instrument? Yes? Look at me, you can tell I play. Okay. if you pluck a guitar string, thank the gods that it eventually dies out, yes? Do you all agree there's an asymptote here? Because what is my function doing over time? Isn't it getting closer to it? But do I go through it? I go through the damn thing an infinite number of times. This is just getting infinitely smaller and smaller and smaller. So this is not a wall. It's a, hey man, you got to get close to me eventually. This is a, holy shit, don't come here. Weird shit happens. Okay, maybe. So vertical asymptotes come from domain. That's why they're so strict. Horizontal asymptotes come from, what's it look like is happening when my inputs get big? So it can go through that as many times as it wants to. All right, so let's come back to this dude. So now we know there are vertical asymptotes at x equal to 4 and x equal to negative 4. There are vertical walls there. And I know that that means it's going to do one of these two things, yes? It's going to do like, you could, no I can't. Can I chew gum and walk? No. Okay. The next question is, what is the horizontal asymptote for this thing? You with me? Okay. So I'm going to keep coming back to this until we can crack it fully. But let's look at some examples. I'll do one last idea, okay? And then I'll let you guys go. I'm cramming a lot of stuff in your brains. I'm sorry. So let's look at horizontal asymptotes a little bit deeper. Do you all agree that if I had a function like this, if I let me do it like this instead. If I let x get really big, let x go to infinity, but my input's really, really big, what are my outputs going to do?
Small.
Yeah, my outputs are going to go to 0, right? And if I let it go to plus or minus infinity, the same thing's going to happen. Does everybody agree? 1 divided by really big positive is 0. 1 divided by really big negative is 0. Is everybody cool? Okay. So watch this. If I have a function like this, and I want to know what the horizontal asymptote is, I'm going to let x get really, really big. Y'all with me? Could x be 0 then, if I'm letting it get really, really big, positive or negative? Do I care about x equal to 0? No, that's the exact opposite of what I care about. I want to get far away from 0. So therefore, now, everybody agree with this? That would go to 0, correct? So watch what I can do. If I divide the top and bottom by x, why am I allowed to do that? Because x is not 0. I'm getting very far away from 0. So I can divide by it. What's x divided by x? 1. What's 1 divided by x? What's 3x divided by x? 3. And what's 2 divided by x? 2 divided by x. What happens if I let x get really big? What happens to this? It goes to 0. What happens to this? It goes to 0. So what do I get? What's the only thing left alive? Yeah, 1/3. Let's try it. Let's try it. What do I get if I plug 100 in? I'll get 100 minus 1 is 99, divided by 300 plus 2 is 302. Right? What's 99 divided by 302? Anybody got a calculator? I haven't gotten my calculator implant yet, so I can't do this.
0.327.
0.327 roughly? Okay. So g of 1,000 would be 999 divided by 3002. What's 999 divided by 3002?
0.332.
And if I kept going, in fact, what is 1/3 as a decimal? Do you guys see how this is approaching 0.33333333? If I kept going, yes. Okay, let me stop. And in fact, let's do this. Here. Go away. What was it? It was x minus 1 divided by, I probably didn't need the parentheses, but yeah. And now let me do this also. Y equals 1/3. Bam! Look at that shit. Look at that shit, everybody. Look at that shit. In both directions, doesn't the red line, which is my function, doesn't it approach the blue line, which is the 1/3? So that is the horizontal asymptote. Eventually, my function must get close to it. What's it doing in the middle? Going crazy, yes? My horizontal asymptote don't give a shit. My horizontal, play as much as you want to function, but eventually you better get close to me. Yeah? Everybody. So we can start to develop shortcuts, thank the gods. Can somebody tell me, on this first one, which does the numerator or the denominator have a higher degree? What's the degree of the bottom? 1. What's the degree of the top? 0. What's degree mean? The number of variables I see. I see 1 here, none here. So what has the larger degree? On the bottom. So the bottom, obviously in this problem especially, grows faster than the top. This problem. And when that happens, I'm going to go to 0 because the bottom is going to grow faster than the top. I'm dividing by bigger. I get small. I go to 0. What are the degrees here? They're both 1. When I have the same degree, look at the shortcut here. Watch this. Didn't we get 1/3? Isn't that the ratio of the leading coefficients? Do you see how that's always going to happen? If I divide by the highest power of the x, I'm always going to be left with a ratio of what was in the front. That's what's going to be left alive. So when the degrees are the same on the top and bottom, my horizontal asymptote is just going to be the ratio of those two numbers. So looking back at the function we keep looking back at, what's true about the degrees? Same degree. So what's the horizontal asymptote going to be? 1. 1 over 1. Okay, so thank the gods we're going to develop some shortcuts. What do you think if, let me say this last thing and then I'll give you, well, no, I'll save it for next time. What do you think, I'll give you the handout next time, which is tomorrow. What do you think happens if the, Jeff, yeah. If the top degree is higher than the bottom, which one's growing faster then? The top is. So the bottom can't keep up. So my outputs are just going to keep getting bigger. So in this case, it's going to go to infinity. This is the weirdest situation. Believe it or not, this is going to lead to what's called a slant asymptote. So I just laid some groundwork for asymptotes. Tomorrow I'll give you this little handout. We'll do it together, and we'll get a little deep. And that'll be it. This is the last section that we're going to do. So we finish that up tomorrow, and then we're ready for the test. Theoretically, huh?
No 3.7? Inversion?
I don't think so.
It's on the homework list, that's why.
Oh, it is?
Yeah.
All right, we'll see if I get there.
Or 5.7, sorry.
5.7, yeah. We'll see if we get there. All right, guys. I'll see y'all tomorrow. Oh, yeah. If anybody didn't get their quiz back, come on up here and get it.